Hey guys, BuildZoid here, and welcome to the 12th weekly HWbot score roundup. We've got epic scores to look at, as we do basically every single week. There is a lot of hardware out there that needs to get overclocked, and so I'm not going to have a shortage of scores anytime soon. And yeah, let's just get right into it. Starting off with Bisso's 3D Mark Port Royal single GPU world record. He already had this record. He just decided to break it again. And I gotta say, I really appreciate that Bisso is over here just posting higher and higher and higher scores as he gets them. Because a lot of other sort of people who have world records in a lot of rankings will often sort of just sit on their best scores until somebody beats their previous best so that they can post the new, the new record on top of that. But yeah, Bisso here has just kind of been moving what the first place score for 3D Mark Port Royal on a single 3090 is up and up and up and up. And so that's really, really cool to see. So 2835, 1481. I think this is basically the same clocks that he ran last time. Yeah, I think this is actually exactly the same clocks that he ran on his previous single GPU record run. But there is a few changes to the setup. So the 3090 is, of course, a 3090 KP Kingpin edition on liquid nitrogen with the Noctua fan sandwich for VRM cooling on this side of the card. I'm hoping there's a fan on the other side of the card, or maybe that side of the card just doesn't run run as hot. And this is all running now on a Z590 Dark. Previously, he was running on an Apex. Still with a 10900K, this time doing 5.5 gigahertz on water cooling, and that's with hyper-threading disabled. Also, Port Royal is not a, there's no real CPU benchmark component to it, so I'm assuming it doesn't run that hot. Though also that seems to just be a really, really good 10900K, as it's doing 5.5 gigahertz with, oh wait, that's vid reading. Okay, so we actually don't have a voltage reading for this. So anyway, still a really strong chip though. Like 5.5 gigahertz is pretty hard to do on like a 10-core CPU just in general. Yeah, the memory is doing what is it? That's actually 4800, 16, 16, 1628 on the memory. So the memory is a bit faster than what I think he was running in the past. But yeah, I guess this is just a case of rerunning Port Royal until the score goes up a bit, which is unfortunate. Like, that's unfortunately a thing with a lot of benchmarks where they're just not consistent enough, especially when they have like 5-digit scores. The last couple digits can float around quite a significant amount, just like on back-to-back runs. So I'm guessing this score is just a case of rerunning the benchmark until he got the score and managed to actually save it. Because I think he got a pretty similar score to this earlier, and just mentioned that the system just crashed as he was trying to save it. So anyway, yeah, 2835 on the GPU. So that the card is absolutely flying. Massive memory clock, especially for liquid nitrogen, because on liquid nitrogen the memory on most 3090s gets rather upset about being too cold. Yeah, like just an amazing score. And if this is actually just a case of like rerun it until it works, then that is some commitment to getting that score. Though I guess if you've seen a high enough score once and just weren't able to save it, like that's motivation enough for a lot, in a lot of cases where it's like, I know it makes better scores, I just need to run it enough times to get it again. So yeah, just an absolutely incredible score on that 3090. Yeah, I guess Bisso is going to be at the top of the 3D Mark Port Royal rankings for a while, considering that he's just been, pushing what the top score is up and up and up over time. So yeah, congratulations to him on improving the world record, because it was already his. It's not real. I guess breaking the world record also works. But yeah, breaking his own record in 3D Mark Port Royal single GPU. And let's move on to the next score, which is Char 00750, running GPU Pi for CPU 1 billion on the 5300G, getting third place with it with 2 minutes, 8 seconds, 538 milliseconds. running in a Crosshair 8 Dark Hero, and man, that screenshot is something. There we go. Now we can see it. So yeah, 5300G, an absolute beast. Like literally, currently the best quad-core CPU for GPU Pi. Just because I'm assuming it has some, like, there seems to be just some kind of GPU Pi just seems to work really, really well on the 5300G. This is a multi-threaded CPU benchmark, and yeah, Ryzen seems to work really, really well for that. And then the 5300G is just, latest iteration of the Zen architecture, so it's faster than all the previous Ryzens, which were already pretty good at GPU Pi, just not this good. And so chips doing 5.323 gigahertz, 2060s, so not really hammering the memory like we see on a lot of other 5300Gs, which is kind of interesting because the APUs should generally do really high memory clocks. Then again, they also get kind of weird on liquid nitrogen. So actually, basically all Ryzens get weird on liquid nitrogen. So that might explain why we're looking at just like 4133, 1414, 1428 here. Also, that TRC is awfully loose as far as I'm concerned. Though it is a 1T. No, that's going to be gear down mode. So not true 1T, and it also looks like the Infinity fabric is desynced. I'm not sure how memory-intensive GPU Pi is, so that might not really affect this score much at all. And still, third place score in the GPU Pi rankings, so way ahead of all of the old, KB Lake quad-core top scores, and really way ahead. Like the KB Lake chips were running in the 3-minute range. And yeah, the 5300Gs are doing, you're getting like low 3 minutes on, or actually even sub 3 minutes on water cooling. Well, that's chilled water cooling, but this is still water cooling as far as I'm concerned. And then, and then almost like very close to just 2 minutes on liquid nitrogen. So yeah, it's just good to see more people getting their hands on the 5300G and pushing the CPU, because this really seems to be the new king of quad-core chips, at least especially for GPU Pi. But AMD doesn't want to sell it to anybody, which is annoying. Like, the thing is, the only way you're getting this CPU is from pre-builts, and I guess you might be able to, like, order it from China, or maybe find it on eBay. Because yeah, there's no like regular retail release for the 5300G, which is really unfortunate. Because yeah, this looks like a really fun CPU to mess with. For quad core benchmarks, as well as just in general. APUs are like GPU benching on APUs is generally pretty fun because it is basically just memory overclocking, but it's a little bit different from your usual memory overclocking, as you're trying to maximize the memory bandwidth for the integrated GPU. Of course, that doesn't factor into GPU Pi. GPU Pi is in this configuration, it is entirely a CPU benchmark. Though you could technically run GPU Pi on the iGPU of a 5300G. It's just 3090s are a lot better at that. So you wouldn't act like that's, the 5300G is not actually competitive in that, but yeah, so just great to see more people getting their hands on 5300Gs and running them on liquid nitrogen. And congratulations to Shar on the third place finish with his 5300G. I'm going to guess this is from like his first session with the chip, so we might see him improve on this score in the future. So yeah, still congratulations to him on the third place with the 5300G. And let's move on to the next score, which is Noisemakers Y-Cruncher Pi 1 billion world record on dual core CPUs with 1 minute, 42 seconds, 246 milliseconds, running on a Core i3-7350K doing 6.5 gigahertz. So Y-Cruncher Pi is a very, very heavy multi-threaded benchmark. It's also extremely memory bottlenecked, and it doesn't appreciate being unstable. So we're actually looking at like really quite tame memory settings here, because like Y-Cruncher, if you try to run the kind of memory settings that you see people running for Geekbench or Cinebench or a lot of the other multi-threaded benchmarks out there, Y-Cruncher doesn't finish. It just won't finish because it is way too hard on the memory controller and the memory system. It also requires just like 4 gigs of memory to even run. So you can't run a ridiculously low maximum on it like you can on some of the other benchmarks. I mean, on Cinebench you can't either. But yeah, just Y-Cruncher in general is basically it's almost Linpack in terms of just how hard it is on the system stability. And 7350Ks generally kind of suck. They don't clock as high as like 7700Ks, and it's not because they're like downbinned 7700Ks. 7350Ks have a completely different die from 7700Ks. They have a 2-core die, much smaller, seems to have a different, worse memory controller, which also doesn't help the memory settings, and they just generally don't clock as high as 7700Ks. However, the 7350K is the last unlocked dual-core CPU, so, you know, it's also the fastest dual-core ever produced, at least until we get CPUs that have so much IPC that with just 2 cores and 4 threads, they can match the performances of a 6.5 gigahertz dual-core Kaby Lake. Which that's probably going to take a while, and we might not even see dual cores like that any like in the future. That might just not be a thing. You know, like low core count CPUs aren't cool anymore. I mean, the 7350K wasn't really that cool either, except from a competitive overclocking perspective, because of the fact that there's dedicated dual core rankings, and there the 7350K is an absolute beast because, well, it's the only unlocked modern, like the only. Well, technically, like, this is only one generation behind Intel's latest, you know, desktop architecture that you can buy. Like, 11th gen is, like, finally we aren't running Skylake cores. So this is not that far behind the IPC of, like, a 10900K, except, like, this has much less L3 cache, a much worse memory controller. The 14 nanometer wasn't quite as refined, so the clocks are kind of low. Though 6.5 gigahertz in Y-Cruncher is ridiculous, like especially on a 7350K. A lot of these CPUs have a really hard time going over like 6.2 for multi-core loads, and so seeing one doing 6.5 in a benchmark like Y-Cruncher is just ridiculous. The motherboard for this was a Maxima. Oh, we can't see it; it's all blurred out. Very nice thermos though. Maximus 9 Apex, the best Z270 overclocking motherboard, basically because it's the only, like, you know, overclocking focused Z270 motherboard. But yeah, that, like, a really great board. And then GT710, because you don't actually need, like, it's a CPU benchmark, you just need something to handle display output. And the memory, I'm guessing it's some kind of G-Skill, though it looks like it has custom heat spreaders on it. Or is it? I have no idea what that is. We can't really see the memory because I think it's insulated to deal with the cold spreading through the board. Also, it's worth noting that 7350Ks, a lot of the time actually need completely different voltage settings from like their 7700K counterparts to run full pot temperatures. And also the smaller die, as far as I'm concerned, is a bigger like thermal paste cracking problem. It took me, like, I ran a 7350K on LN2 a long time ago, and it took me forever to just get to full pot temperatures with, like, the CPU actually running properly. And then it only topped out at, I think little bit over 6 gigahertz, if I remember correctly. So, yeah, 7350Ks are, like, they're really cool because they're sort of, well, if they weren't kind of like the problem with them was that when they released, or kind of the problem with them now is that when they released, they were kind of expensive and they didn't really make much sense from a performance perspective. And so they're kind of rare, but they are really cool as a sort of like cheaper modern CPU that you can mess with, even though they really don't compare to any of the other Intel chips they don't compare to the newer Intel chips in terms of overclocking behavior very well, just because like the memory controller isn't great, the cores generally aren't great, but they are really interesting CPUs to run, and you know, just I wish we had more low end overclocking options like that, right? Like really cheap the thing is, the 7350K wasn't that cheap, but it would be cooler if we had some more, you know, budget CPUs like the 5300G, like the 7350K. Like, I consider this a similar chip to the 5300G in terms of why it's cool for overclocking. Though I think the 5300G is actually soldered, so that's much easier to run because of that. Anyway, Yeah, it's just insane to see a 7350K doing, 6.5 gigahertz for Y-Cruncher of all things. Um, and yeah, so Noisemaker has the record in this now, and he's actually doing, like getting that record with. I wonder if it's literally just memory settings, though. With Y-Cruncher, you do also get to mess around with how the benchmark runs on the CPU. So you can sort of tune it for that, though. It looks like this is all on auto, so let's take a look. Is it just memory? This is running 4133 though. Is it Encore? No, that's 6.2. That's 6.2. Oh, wait a minute. Noisemaker's running lower TRFC. This is 2T command rate. Yeah, that would do it. Yeah, that would do it. Y-Cruncher is very sensitive to memory settings. It would be interesting if somebody found a 7350K that didn't have a memory controller that's like completely trash. But yeah, because like with a 7700K on liquid nitrogen, you could actually we could just check that. I don't have to make a guess. We could just go. Nope. We need to go through the hardware rankings. Now it's not going to load. Yeah, so quad core KB Lake. And we have a 7740X doing 55 seconds. And that is running, yeah, 14. Well, yeah. The thing is, the TRCD timing is actually really hard on the memory controller, so it's not too surprising to see 14, 18, 18. This is admittedly at 3866, also lower Encore. Yeah, this is a really hard benchmark on the memory controller. We have another LN2 7700K. Let's check this one. Though this is probably going to be terrible in the memory settings. Yeah, this is like... Yeah, like Y-Cruncher takes your memory set, like your benchmark memory settings, and brings them back down to reality. Because it's like, it's not stable with the kinds of things that you would expect to run in other benchmarks. So yeah, just a very, very impressive score, from Noisemaker here on the 7350K, because these CPUs, you'd think they would be just like smaller 7700Ks, but they are actually very different. And much weaker, almost at everything. So congratulations to Noisemaker on the world record in dual-core Y-Cruncher Pi 1 billion. And let's move on to Senz's Cinebench R20, third place in the 10-core CPU category, using the 10900K, doing 6.87 gigahertz. Which, I mean, third place in Cinebench is basically just a CPU frequency test, so in terms of, like, with Intel chips, it does care about memory somewhat. Not, like, on AMD CPUs, it basically doesn't matter what your memory settings are. On Intel ones, it does, because Intel doesn't have anywhere near as much L3 cache. And also, there's probably just something down to how Intel CPUs work compared to how Ryzen CPUs work. But... yeah, so 6.87 gigahertz, like almost 6.9 gigahertz on that chip. So, absolutely flying for a relatively hot multi-core workload. Not the hottest, but a relatively hot multi-core workload. Cinebench R20 is, and then uncore frequency of almost 6.2 gigahertz, which with the big high core count CPUs, running high uncore is actually really quite difficult. Just because the uncore frequency is actually sort of the ring frequency of the Intel CPUs, and well, the more cores you have, the bigger the ring is, and therefore the harder it is to get it to do high frequencies. For the memory, we're looking at 4800, 14, 14, 14, 28, which is, standard Comet Lake. Yeah, that's sort of your standard high, like, maxed out Comet Lake memory settings right there. At 2T command rate on a Maximus 12 Apex motherboard. Running a Der Burner LN2 pot, I think. Yep. That's a new one, I think, which is tuned for even higher heat loads than the previous version. And yep, if you run long sessions, you eventually get like the cold air from the liquid, the cold nitrogen will freeze condensation all the way into your fans if you run long enough session. It's kind of annoying because at some point in the session you need to start clearing out ice from your vapor management fan. Anyway, and over here we see that the CPU is lapped just to, maximize thermal transfer between the IHS and the actual LN2 pot, and then Kingpin Cooling KPX thermal paste for the thermal paste. So, also that is I can't tell what he insulated with. It might be clear electrical tape. Because, yeah, that really doesn't look like there's... Yeah, it almost looks like there isn't any insulation, which Vaseline normally is... Like, you can usually tell that a motherboard is covered in Vaseline because it gets everywhere. But this looks really clean, so I'm guessing it has to be clear, or at least or he's running the board naked, which is pretty brave, depending on if you have a socket heater or not. But yeah, a very, very solid score, right? Like, third place in Cinebench R20 is very competitive ranking. 10900Ks are, well, quite hard to clock really high. At least, like, they do at least have soldered IHSs, so you don't have to deal with the thermal paste failing all the time. And yeah, so a very, very, very impressive score from Sens there, getting third place in the 10-core Cinebench R20 rankings. Congratulations to him on that, and let's move on to the next score, which is Ralph's 3D Mark Port Royal top score for the RTX 3080 Ti. Now, there's not a lot of competition for the 3080 Ti's in Port Royal. It's kind of weird. There's not a lot of competition, but the competition that there is really hard, right? The top 4 scores, we're looking at a 2715 core, a 2775, a 2805, and a 2820 from Ralph. So, yeah, with 1419 on the memory. And the crazy thing is, if Ralph didn't have a higher 3090 score for the overall, like the overall 3D Mark Port Royal single GPU rankings, his 3080 Ti score would actually be the 4th ranked 3D Mark Port Royal score. Because, yeah, you can see it right here. Or more like right here, right, where you have Bisso at the very top, then OGS behind him, Lumi behind that, and then we have Ralph with the 3090, Ralph with the 3080 Ti, and then we have OGS with the 3080 Ti. So I guess that really shows how little of a gap there is between the 3090 and the 3080 Ti. I still really wish there was a 12 gig 3090, just because, like, the extra VRAM on the back of the card is, like, for Port Royal, it doesn't give you more performance, and it's just more memory chips to worry about. Theoretically, it should also be like if a GPU manufacturer actually decided to start binning the memory chips, a 3080 Ti would be way easier to, like, have all the memory chips be really good instead of a 3090 where you have to get 24 memory chips that don't suck. Whereas on a 3080 Ti, you only need 12 of them. So yeah, that's my biggest complaint for the 3090. It's just like, it's got too much VRAM. Like, this is actually a problem. But anyway, the cool thing about Ralph's setup here on the 3080 Ti is actually his massive backplate heater. So this is 2 Kingpin Cooling Infernos. So these are, like, normally these are meant to be like CPU socket heaters. He's adapted them using a very thick copper plate and then a massive thermal pad for heating the back of the card. And this is basically to manage the temperature of the memory chips and to prevent condensation buildup on the PCB of the GPU. You need a lot, like, each of those heaters is, I believe, 150 watts. So that's like 300 watts, up to 300, like, they won't ramp up to full heat output unless they need to. They are temperature controlled. But yeah, that is a lot of cool, like, heating in order to compensate for just the cooling that the LN2 like that's passing through the die and into the PCB and then, wreaking havoc on the memory overclocking. So yeah, that's a really interesting thermal, like, management setup for the 3080 Ti there. And I guess this might be pre-testing for more runs on Ralph's 3090. Also, this is a Hall of Fame 3080 Ti, and I think it's really cool that Galax is actually making like extreme overclocking making extreme overclocking cards that aren't just the top of the line, right? So if you don't want to pay 3090, well, I feel like the 3080 Ti is just like it's just 2% more cores, please, NVIDIA, so that it would actually compete with the 3090 properly. Because yeah, right now it's just like you're never gonna like at the same clock. So 3090 has a slight core count advantage, so you're just not gonna beat it, which it has to be frustrating, but it's still cool that you do get the option to get 3080 Ti's that, you know, have the same build quality as the top of the line LN2 overclocking focused 3090s. I'm kind of sad that the like really ridiculously over like it used to be that like MSI had Hawk cards which you could get like a 670 or even like a HD 7870 with a really nice overclocking focused PCB, and these days we don't really get that anymore, and I think that's a shame. But yeah, it's nice that Galax just sort of like the thing is ultimately they didn't really need to do. Actually, no, you'd have to adapt the PCB quite a bit because 3090s have all those memory chips on the back, whereas 3080 Ti's you don't have the memory chips on the back. But yeah, a really cool score from Ralph there. You know, with the 3080 Ti here. Also, is that a memory heat spreader to support the weight of the LN2 pot? Yeah. So if you were wondering how do you keep the super heavy, you know, containers from like bending the card forward, you just have to pad them with normally just shop towels, but you know, memory heat sinks work too. I don't think that's an entire memory stick. And this is running on a Maximus 12 Apex with a 10900K doing 5.3 gigahertz, which is, you know, what the norm. RAM just doing 4000 CL15, and yeah, 2000 watt super flower power supply. So I don't think that actually is necessary for this setup right here, but for multi really like that's a really cool PSU for like really massive multi GPU setups. Though actually at some point you do need to like for quad GPUs you would actually need two of those potentially. Because a lot of the 3080, like a lot of the big NVIDIA cards can quite easily go up to like 1000 watts of power draw on liquid nitrogen. And so, and that's true for even like 980 Ti's. So if you were running four of those, you'd need, like even then you'd still need a second 2000 watt power supply. Or even just three of them, you might need a second 2000 watt, like a second power supply anyway. But here, this is a single GPU setup. So that's not necessary. And yeah, so just a really awesome score here from Ralph on the 3080 Ti, and congratulations to him on almost beating his own 3090 score with the with a 3080 Ti. Like that's really cool. That though it also just kind of makes sense that 3080 Ti's aren't very far behind 3090s. But yeah, awesome score from Ralph, so congratulations to him on that. And let's move on to the next score, which is Tag's SuperPi 32 million on the E2200 doing just under 5.2 gigahertz. And Tag has been on an absolute rampage when it comes to using a rampage, when it comes to LGA 775 benching, and just like it feels like last week he broke so many CPU top scores, like CPU specific top scores, that I just basically took two of his scores at random, and I was like, look at these, and then he did so much more. And this week it continues. Yeah, so it's Rampage Extreme still going strong. Liquid nitrogen on, well, all of the CPUs, I think. Yeah, doing 5.2 gigahertz on the CPU. What is that? That's 1886.75 on the memory timings with TRAS of 20, 1T command rate. I'm pretty sure that even by like X48 standards, that is pretty low on the memory. Then again, this is probably limited by CPU frequency. I don't know anything about LGA 775. Also, he absolutely smashed the first place for the E2200. Like this is like a, what is that? That's like a 20 plus second gap. No, that's like a 33-second gap. He improved like this really seems to be just CPU frequency limited. And yeah, so he absolutely smashed the previous record with the E2200. Actually, was that still on liquid nitrogen? Oh yeah, that was on LN2. Though most of the other... Oh, whoa, these CPUs seem to be a mess. Considering we have a 4.4 gigahertz on liquid nitrogen over there. Interesting chips. Well, the thing is, I don't know anything about 775, so I can't imagine these are too expensive though. As these are what? Yeah, dual core CPUs. Um, which I guess is true for basically everything that fits into the LGA 775 socket at this point. It's just like you can probably get them really cheap, regardless of what exactly it is. Because these CPUs are just so old and so very slow. But yeah, 2 volts to get almost 5.2 gigahertz out of this CPU and absolutely demolishing the previous record. Also, this is a capped modded CPU. Apparently, I'm guessing this is one of those chips that came from like a bucket of just CPUs. And so it was missing a lot of capacitors, and Tag added like, well, he didn't fix it. He didn't put all of them back. Like, he didn't replace all of the missing ones, but these 3 that were missing, yeah, he replaced those with yeah, 322 microfarad caps, and apparently that helped with like 60 megahertz more core clock. So more caps. We need to see more caps on this, as far as I'm concerned. Like, if it's scaling, it needs more caps. Like, you need to keep adding capacitors until the frequency stops going up. I'm guessing like so the interesting thing about adding capacitors to things instead of just raising the voltage is that as you raise the voltage, your heat output goes up. So and basically, like, the reason why adding capacitors gives you a overclocking improvement is because when you add capacitors, it improves the minimum voltage during a transient. So as the CPU is running instructions, it's going to be pulling, varying amounts of current, and when it tries to pull a lot of current, the voltage dips because the VRM just cannot respond instantly. There's many we're not going to get into the reasoning. The VRM cannot respond instantly to current draw, like changes in current draw, and even if it could, you still have a power plane. The power plane has a bunch of inductance to it. The power plane isn't going to allow that voltage change to happen instantly either. Basically, everything between the CPU and the power delivery cannot respond instantly. And so that's why CPUs have a bunch of capacitors directly behind them to deal with the initial really fast load spikes. And of course, if some of them are missing, then the CPU is not going to be clocking quite as high as it maybe should be. And so adding, having the capacitors on the back of the CPU basically means that when the CPU suddenly needs a lot of current, the voltage dips less. And if the voltage dips less, that means you can run higher frequencies, because for a given frequency, there's going to be like a minimum voltage that you need to be able to sustain so that the transistors can complete their switching in time. Because if the voltage dips too low, then the transistors start to switch slower. And that's when you start getting errors, because the CPU is like, I'm running at 5 gigahertz, and then one or like a few transistors don't manage to complete a transition in time, and a 1 ends up being read as a 0, or a 0 ends up getting read as a 1, and you've got a blue screen and a crash, and everything is horrible. So the cool thing about capacitors is that you can actually improve the minimum voltage without changing the average voltage, because if you increase the average voltage, your heat output goes up, and of course, like, one of the reasons that liquid nitrogen makes CPUs clock higher is just the temperature of the transistors itself, or the temperature of the silicon, reduces how quickly, makes it possible for transistors to switch faster. That's the way I wanted to say that. So with capacitor mods like this, they're generally not going to give you massive improvements in frequency. But they're going to give you free improvements, because they're not going to add any heat out. Like, they don't add any extra heat output to the silicon. The silicon's going to be still the same temperature, but your minimum voltage goes up. And also your overshoot goes down, which overshoot can, in some scenarios, cause timing issues. A lot of the time it's just completely irrelevant, though it can sometimes also cause damage. Though, again, if you're on liquid nitrogen, that's not really a concern. Like, the bigger concern here is that the average voltage is almost 2 volts anyway. Yeah, so really just cool to see somebody, like, I tried to cap mod a CPU, but I did it on a 7740X, which is probably like the worst candidate for a CPU cap mod ever. And yeah, so it's just really, really cool to see actually somebody do a CPU cap mod and have a successful one, because mine basically didn't do anything, which makes sense. Like the 7740X is basically Intel factory cap modding a 7700K. So, it's like, man, of all the CPUs to choose to do that with, that was probably the worst possible choice. But yeah, this chip, it was already missing capacitors, so I guess when the starting point is literally below the stock configuration, there's more room for improvement. Yeah, really, really cool score from Tag here on the 2200, and he also, of course, smashed the record, or well, he didn't smash the record for the E4600, but he did take the record for the E4600 at 9 minutes and 49 seconds, again on the Rampage, because as far as I'm aware, this is basically one of the best, if not the best, LGA 775 overclocking motherboards. Yeah, this time, just 5.0, 5.06 gigahertz on the CPU. Memory clocked a little bit lower. I'm assuming this is, again, just like the memory clock here is probably just a function of what bus clock is necessary to achieve the maximum CPU speed. So the memory could very well go higher, but it's just the CPU can't run high enough FSB to do that. And then in terms of the ranking, Tag has really good efficiency again, as he is beating a score that's clocked almost 100 megahertz higher than his is. So is that just a memory settings difference? Though with SuperPi, there's a lot of like OS level stuff you can do, like well, yeah, there's a lot of weird software tweaks that you can do for SuperPi, and I suck at that benchmark, so we're not going to get into them because I'm not gonna do a good job of explaining it. Yeah, I'm gonna assume this is just a memory difference, because this, sure, the timings are actually, they're not really tighter, because this is what, 666, 15 with that's TRFC 48 versus 60, but this has more memory frequency. And, yeah, you have CL675. So, evidently this is faster. Also is this, they're both at 1T command rate. So, yeah, but I'd still say that, like, to me, this looks like it's mostly just a memory configuration difference. So, Tag managed to run better memory settings and a close enough, like, the SuperPi is memory sensitive, but it's not so much that you can, well, depends who you're going up against, but, or how bad the memory settings you're going up against are, but you do still need to be at least sort of close to the frequency of somebody else if you want to just beat them on the memory settings alone. And that, at least to me, certainly looks like what's happening here. So, yeah, congratulations to Tag on sort of continuing his rampage across the LGA 775 rankings with his rampage. And, yeah, congrats to him on this E4600 top score. And let's move on to the next score, which is Yossarian Lives and his Y-Cruncher Pi 1 billion, top score for the Xeon W2225. The crazy thing about this is not the first place in the 2225 rankings, because I think Yoss is literally the only person to ever run one of these. For some reason, he has it on a single stage. Oh, I guess that might be just to, because this is a Xeon. So, and I believe, yeah, this is a Cascade Lake W Xeon. So, he's the only person to ever run one of these, because, like, this is a super weird CPU. It's also not that cheap. I tried to look it up on eBay. Not a cheap CPU, as far as I can tell. So, but anyway, the cool thing about this CPU, specifically for Y-Cruncher, is that Y-Cruncher takes advantage of the AVX512 instruction set, and Y-Cruncher also loves memory bandwidth. And you will notice that though this is just a quad-core, it does have a quad-channel memory controller. So it has a ton of memory bandwidth, even though it's only running 1463 megahertz, so that's 2933 on the memory, and 32 gigs of RAM. I'm surprised he didn't run dual rank. Maybe it wouldn't have worked. Maybe he does. Maybe it needs registered DIMMs. I'm not really sure. But yeah, so 2933, 12, 12, 12, 28 with 1T command rate, because at frequencies this low, yeah, 1T command rate is super easy to run. I'm assuming the single stage phase changes to reduce the, like, the thing is, as you reduce the operating temperature of CPUs, not only do they clock higher, they also pull less power. And so I'm assuming the single stage phase changes here to get the CPU to boost more, since if it's colder, it should it'll pull less power and therefore hopefully sustain a higher frequency. Or maybe he just couldn't be bothered to mount regular cooling system to the motherboard, which is super weird as far as I'm concerned. Because I would have always considered phase change to be more of a hassle than a water cooler. But either way, really weird CPU, right? And we have, yeah, AVX 512 support, the quad channel memory controller. And so the crazy thing about this score is that even though this chip is barely doing 4.5 gigahertz, it's not even doing 4.5 gigahertz. The effective clock readout from Benchmate here is that it's not even doing 4 gigahertz. And the max power draw was only 72 watts. So even though this CPU is like not really running very fast at all, it manages to get 10th place in the Y-Cruncher rankings because Y-Cruncher is such a well, AVX 512, right? Whereas none of the other CPUs here have AVX 512 support. So that's already a massive advantage in favor of the W2225, but also the quad channel memory controller. Y-Cruncher is a massive, loves memory bandwidth. And so, yeah, the quad channel memory controller should certainly be helping with that as well. Though, yeah, no, the funny thing is, like, 29, the thing is, you can technically outclock the memory bandwidth of a quad channel memory controller with a dual channel memory controller. You just need a, massive disparity in clock speed. So basically, for a 7700K to compete with a quad channel or a 7740X or any, for a dual channel CPU, to have comparable memory bandwidth to a quad channel CPU, you would need the quad channel CPU to be running 2133 and the dual channel CPU to be running 4266. Literally double the clock speed in order to make up for the lack of memory channels. And so at 2933, that Xeon W should be pushing, the equivalent or close, should be pushing around the equivalent of what is it, 5866? Yeah, something like that, dual channel 5866, which that's not really viable for benchmarking. That kind of frequency isn't. So yeah, and then also you have the advantage with quad channel where you actually have channel interleaving. So if one memory channel is busy, you can actually, it's like rank interleaving, but across the memory channels now. So there's further efficiency gains from just having more channels than just the fact that, if you're getting perfectly organized reads and writes, quad channel has double the bandwidth for a given speed compared to dual channel. Also, if you're not getting perfectly, queued up memory commands, quad channel still has a throughput advantage just because you have more channels to play with and the memory controller can organize the data to accommodate for irregular memory access a bit better. And so, yeah, so this is a really, it's not really the memory, it's not really overclocking, it's just timing adjustment, which technically kind of it's still it counts. I consider this overclocking. Very weird overclocking, very unique overclocking. Literally the only person to run a W2225. But I think it's just so cool to see, a score like this on a CPU like this, and to just see imagine if Intel just let us overclock one of these. That would be so cool. We would have a quad core that probably, so this thing's pulling 72 watts at 40. Assuming that measurement's even accurate, but at 4.5, that sounds low. Sounds a bit low for 4. Then again, it is on phase change, so that might be that would be part of it. Yeah, but you could probably get with the AVX 512 support, you could probably get a quad core to pull over 200 watts easy. If it actually was overclockable. So it's a real shame that all of the, even the low-end Xeons are locked. This I think would be, right now it's expensive and nobody would really want to buy it, but it would be interesting to see what would be possible if we had a proper quad-channel quad core instead of, having to run dual-channel quad cores in the Y-Cruncher rankings. Anyway, let's move on. So congratulations to Yoss for digging up a very strange and unique CPU. And let's move on to the next score, which is Shaggy SVK's 3D Mark Firestrike, second place using the GTX 1066 gigabyte JP106 core. because of course NVIDIA, in their like NVIDIA just has like a million different version of the GTX 1060 with a bunch of different cores, because of course they do. Like to be fair, like the thing is, this is a standard NVIDIA thing. There's like a million different versions of the GTX 560 and also the 560 Ti, which is, you know, yeah, NVIDIA things. What do you mean product names like imply a certain level of specification? We're just going to change cores and die configurations and everything on the fly. Anyway, the crazy thing about this 1060 right here, so you know, I've featured Shaggy SVK in the previous roundup with this card. This time he actually got it to run full pot on my suggestion to just try cold boot, like boot it at full pot. So apparently that worked. So the interesting thing about Pascal cards and running them at full pot is that, by which I mean running them at the lowest possible temperature that your LN2 pot will allow, is that a lot of Pascal cards will actually just sort of have a cold bug. And it's because of the temperature sensor glitching out. And so so with some cards, you'll get lucky and the temperature sensor glitches out in a way that it doesn't shut down the card at low temperatures. And with other cards, you get unlucky and it shuts down the card when you're at like -80 or -100. But the interesting thing about these cards that, you know, bug out and shut down at -80, -100 is that sometimes you can actually still boot them at -180. Because they, like, Pascal doesn't have a cold boot bug. If you have one of the cards that goes all the way to full pot, like, you can boot it at full pot. There is one weirdness with them. They don't like booting at high core voltage, in my experience. You need to boot them at low core voltage if you're at really, or actually, I think maybe even in general, you need to boot them at low core voltage. Like, I tried to boot a 1080 Ti at 1.6 volts, didn't like that. But, yeah, once you get them to full pot, well, some of the cards that'll cold bug in, like, the medium temperature ranges of, like, -80 to -120, they will potentially boot right up at -180. And so you know, which I didn't discover that. I heard that from somebody else. And anyway, I suggested that to Shaggy SVK, and he managed to get the card booting up at full pot and consequently clocking it even higher than before, as it's now doing 2569 for 3D Mark Firestrike. And it does have the e-power, so the VRM on this card was originally some crappy 3-phase thing. Well, now it has a 12-phase V-core. And unfortunately, we can't really see the attachment in this screenshot over here. Also, you can see how they moved the memory VRM inductor to the back of the board, as well as the memory capacitors to the back of the board, just to make room for the power board. Also looks, oh yeah, so they have a wire running over here to feed 12 volts from the e-power to the actual GPU, because the GPU still has the memory VRM running, so you do still need to supply 12 volts power to the memory VRM. So that's what that's for. And then of course we have the little voltmeters sitting on the top edge of the card just to get voltage readouts. So you also have like, the thing is, the e-power onboard readout reads out on the e-power. It doesn't read out GPU side voltages. And as far as I know, the goal for this card is to eventually get 3 gigahertz in, I think, GPU Pi. Which I think, like, because the thing is, for Firestrike, the highest clocked cards are, well, you know, pretty close to 3 gigahertz, but definitely not at 3 gigahertz. So it'll be interesting to see if they manage to push this zombie 1060 to even higher speeds. And right now it's in second place because it is getting, you know, kind of carried by the 9980XE over there with a 41,000 points physics score, as well as a combined score of 6,865 points. The memory is... What on earth is with those memory settings? That's DDR4 3000 1098? Really? Is that seriously optimal for this? That is a really unique way to run a Cascade Lake X, I mean Skylake X CPU. Because Skylake X chips are normally pretty easy to get up to around 3600. Oh wait, no, that's 3200. 10. That's still, yeah, that's still super weird. Why would you be running 3200 1098? Also, it's only dual channel. That actually, like, that hurts, as far as I know. That hurts quite a lot, because the crazy thing about the Skylake X CPUs is they actually have 2 memory controllers on them. So they're kind of Threadripper-y in that sense, where you have 2 memory controllers, one memory controller on one side of the chip, the other memory controller on the other side of the chip. And the thing is, the proximity of the cores to the memory controllers actually affects the performance of the CPU. So you will get a like a performance benefit running quad channel just because you have like all of the cores have a nearby memory controller instead of some of the cores having a far away memory controller. Which, you know, like this is a 16, well, this is an 18-core CPU. Admittedly, he's running it in 16 cores, 32 threads, because Firestrike does not scale above 32 threads. So you do not actually want to have more than 16 cores for Firestrike, because that can hurt the score. Also, having less cores active means you can potentially push the clocks higher, and here that CPU is doing 5.3 gigahertz on single stage phase change. So it is absolutely flying. And that is on a Rampage 6 Apex. And this is Firestrike, so I'm not too surprised that the VRM is still in one piece. Yeah, so really cool to see this card in action again. And then for 3D Mark Vantage is actually going even faster. And here the 99XE is in 16 cores, 16 threads, and they forgot their memory tab. Oh, well, they plan to run the card harder anyway. Like, since they're still working on improving on improving the card, I don't think that's too much of a loss. But yeah, this score is missing a memory tab. That's a problem. You need to include a memory tab. I've done this so many times myself. So forgetting the memory tab. And the reason why we like screenshots on HWbot require a CPU tab and a memory tab is to make sure that, you know, the score that you're getting in the CPU test is actually possible. Based on the settings that you're running. So anyway, but here the card's doing 2607 with 2500 on the memory, which 2500 for Firestrike as well. I wonder if they tried the hotkey thing for Firestrike, because when I was running the 1080 Ti, the trick that I found for getting higher clocks for GT1 and GT2 was to actually change the clocks like a few seconds after GT1 started running. Because for whatever reason, if you tried to start the test at like full speed, it would crash like within the first couple frames. But if you started like with the 1080 Ti, I think I'd start the test at like 2400, and then after like 3 seconds, I'd clock the card up to 2500, if I remember correctly, something like that. Like it was a pretty big frequency step. Yeah, that really helped with stability, so that might be worth trying on the 1060 as well. But yeah, good, like great progress on this 1060, and hopefully we'll see this card doing 2800 eventually. It's certainly, I don't think it, like if this is actually the running voltage of 1.3, then this thing isn't maxed out. Like Pascal should well, I don't know. 1080 Ti's apparently might scale better than 1060s. I don't have a ton of experience with Pascal on LN2. Yeah, like there's certainly voltage headroom. Whether or not it'll scale, I guess we'll find out in the future. If we end up seeing this 1060 doing 2800 in the future, that would be awesome. And, you know, then 3 gigahertz for GPU Pi. So, yeah, congratulations to Shaggy SVK on getting the 1060 running at full pot this time. And just the fact that it still works, because that has an e-power attached to it. And these are fiddly to set up, to say the least. Anyway, next we've got, next score. We've got Salty Croissant with his R9 295X2. Taking the first place in Firestrike Ultra, doing 1215, 1575. And this is on chilled water cooling. VRM heatsink held in place by a rubber band. I'm guessing the heatsink doesn't attach to the heatsink probably attaches to like the base plate, and then the base plate attaches to the PCB, so the heatsink itself doesn't attach to the PCB. And the funny thing about 295X2s is that they have actually a 4-phase V-core, which is very concerning. If like this is a card that from the factory ships with a 500 watt power draw, and it has a 4-phase V-core. So you really need that VRM heatsink, which also probably explains why AMD opted to have a VRM heatsink built entirely out of copper instead of like a sensible material like aluminum. Because the copper is, you know, like twice as thermally conductive as aluminum, but also ridiculously expensive. And in most scenarios, having a copper heatsink doesn't really do anything for like, doesn't really have any worthwhile benefits, which is why we don't normally see copper VRM heatsinks, because it's just excessive spending for minimal gains. But yeah, with a four-phase trying to power, you know, with a four-phase VRM trying to power a Hawaii core, yeah, you kind of need an excessive cooling system, because there's only so much you can do to, like, even if you have a really efficient four-phase VRM, you can't really get around the fact that the thermal density is going to be insanely high, because you've got a lot of MOSFETs in a, well, not even a lot of MOSFETs, you've just got a lot of power going through a very small VRM. So even if it's not producing, like, percentage-wise, like, efficiency-wise that much heat, it would still end up getting quite hot. And so, yeah, copper heatsink. Zip tied on water blocks, again. The problem, so zip ties are certainly a great way of attaching, well, anything to anything as far as I'm concerned. The only issue with them, it's also very easy to over-tighten the zip ties and potentially flex the PCB to the point that you break something. So that's the one downside to them, but they are certainly capable of, you know, holding water blocks in place. And then we have this Play-Doh looking material, which I really hope isn't actually Play-Doh, for thermal insulation. Because of course you don't want condensation build up behind the cores, and the chiller that the Salty Croissant is running is not that strong. I think he runs it at 0 degrees Celsius, or yeah, 5 degrees idle, so I think that's a 0 degree water loop. Anyway, card's absolutely flying. Like, doing over 1200 core on a 290X in general is pretty hard. On a 295X2, well, you've got two 290Xs on one PCB. You can't have as nice power delivery as you can have on, like, the full-size 290Xs. And actually, this is... I would suspect that the VRM on the 295X2 is actually worse than what you would get on a reference 290X. So this kind of core clock is actually very impressive. Then the 1575 on the memory is not bad by 290X standards. Like, certainly higher memory speeds are possible, but it is very difficult. The 512-bit memory controller on the 290X is a bit fiddly. And also, these large 28 nanometer AMD GPUs also tend to have black screen issues, especially at high voltages. And there's also some, specifically with 290Xs, there's some weird interactions between the core speeds and, like, core voltage and the memory frequencies that you can run, though that seems to depend a lot from, like, card to card. Some cards do it more so than others. But yeah, so for a 295X2, this thing is, you know, flying. Though it'll be interesting to see if he manages to push it further, because he, like, I've heard that this card actually did higher core clocks than this, but not with, like, the memory speed was so low that you couldn't actually, like, the score wasn't good enough. So ultimately, you know, with this card, you're, like, trading core clock for memory clock, which you don't really have to do on a lot of well, in my experience, there's a lot of GPUs where you can run basically the exact same memory clock regardless of what your core clock is. So yeah, there's some GPUs. So I'm not sure how common it is that you actually need to give up memory, like trade memory clock for core clock. Because I normally just max the core clock and then I max the memory clock, call it a day. Don't really notice too much of a difference between the two. A lot of don't see much of a relationship between those two a lot of the time. Yeah, and then we've got a 5900X running 4.7 gigahertz with 1.28 volts. This chip is just insane. Really, really great chip. 12 cores, 24 threads, 3933. Yes, 3933, 14, 14, 14, 28 memory timings. Dual rank on a B550E Strix motherboard. And yeah, Noctua fan for cooling the VRM and well, actually, we also have fans on the back of the card because, well, isn't there memory chips on? Yeah, you've got memory chips everywhere on these. There's just not enough space on the PCB for what is it? Like, it's only 8, like, the thing, it's not actually that much VRAM. It's only 8 gigs if I remember correctly. Isn't it? Where's GPU-Z? Yeah, you only get 8 gigs of VRAM total on the card, which 4 gigs actually usable because each core has 4 gigs. But the thing is, you have a 512-bit memory controller, so you need 16 memory chips off the top of my head per core. And there's just not that much space on the PCB to do that. So yeah, you end up with a bunch of memory on the back. And that's standard for most dual core cards, that you end up with a bunch of memory on the back because there's just not enough space for, like, because you need, like, for a given memory bus width, there's a minimum number of memory chips that you have to have. And so, yeah, with the bigger cores, like 384 bits wide and 512-bit wide cores, you got no choice. There's going to be memory chips on the back. So, yeah, dual core cards are just so ridiculous. Like, there's such a bad idea from, like just everything, because so much power consumption in so little space. And like everything is just crammed together as much as possible. And I love them for that. Like they're just awesome in terms of a sort of like really impractical GPU designs from an overclocking perspective. Obviously, if you just want to cram as many cores into a system as possible, then yeah, it's great. But from a sort of like, how do we get all the things a GPU needs on a PCB and then also make a GPU that doesn't run insanely hot? Very, very impractical. Because you also have to add on the PLX chip, which is hanging out over there. So yeah, awesome score from Salty Croissant on the 295X2, and I think he has future plans for this. Yeah, BIOS modded with 1375 timings, going to be modding the PEX rail, which that helps with the black screen issues a lot of the time. And also, I'm pretty sure that's a MOSFET, not a controller. The 4901, I'm pretty sure, is a MOSFET. I believe the PEX should be handled on these cards with an NCP 5230 or a 5320. I can't remember which way the part number goes now. There's a 5, there's a 2, and there's a 3 in it, and there's a 0 at the end. I remember that much, and it's an NCP thing. Like, it's a on-semiconductor part, and that's like a really popular voltage controller for minor rails, for AMD GPUs, from the, like, 290X up until the Vega cards. Actually, no, maybe even past the Vega cards. Like, AMD's been using that controller for ages. So yeah, still, congratulations to Salty Croissant on the Firestrike Ultra first place. Actually, I want to see some of the other scores here. Yeah, actually, literally the highest clocked 295X2. And this is a water-cooled card from the factory, like with a custom water block. I guess ran out of voltage. Like, this thing actually, like, this is wait. Yeah, this is the Ares card. So, I guess he ran out of voltage on this one. Because, this has a proper VRM, assuming it's an actual Ares 3. Wait, we can't really. No, it's gotta be. Like, it's got the back plate. It's got a water block of some kind. So, yeah, anyway, so congratulations to Salty Croissant to just actually, well, outclocking literally everyone in the 295X2 rankings. Let's take a look at the last score of this week's roundup, which is Gary SS3282's third place on the RX 6900 XT in 3D Mark Time Spy, doing 2700 core, 2150 on the memory. Imagine, and I'm assuming this is a vanilla 6900 XT, not a unlocked 6900 XT. Because he has a water block on it. And that's like a custom water block. And as far as I know, the other, like the various custom cards, don't come, like there's no, wait, actually that has 3 8-pins. What is that? What card is that? Power color. Oh, it's got to be a Liquid Devil then. Wait, is it not the ultimate then? Right, where's GPU-Z? 6900 XT. Where does it say? Does it not specify the core revision? Navi 21. Oh, it doesn't specify the core revision. What a shame. But still, a, very solid score in the Time Spy rankings for the 6900 XT with a 5950X that's absolutely flying. 4.9 gigahertz for Time Spy, 19,000 point CPU score. Man, this screenshot. Get a smaller monitor. There's people in there, like, what even is this? This has to be 3440 by, 1440? Yeah, 1440, I think. Yeah, 5950X, absolutely flying. Dual rank, Samsung B-die, because, I mean, it's 14, 15, 14. What else is going to do that? His TRC is kind of loose. His TRAS is also kind of loose. And Time Spy is actually quite memory sensitive on the CPU test. It also doesn't scale above 16 threads. So if you have a 5950X, you want to run it at 1616. If you want a big CPU score in Time Spy, you need to run it in 16 threads. 16 cores, 16 threads. And that is that's quite a lot of voltage on that 5950X. Is this just regular water cooling or is this chilled? This looks really like regular water cooling. Well, I mean, I guess I'm comparing my AIO to a custom loop, so my expectations, like, AIOs are pretty good, but they're more like big air coolers than they are like custom water cooling loops, if anybody was wondering. So, yeah. Anyway, still a really, like, solid overclock on that 6900 XT, right? Getting third place in the Time Spy rankings there. And also just, like, great work on the 5950X, like 4.9 gigahertz, and then, you know, over 19,000 point CPU score is a very, very solid result for Time Spy. So, yeah, and that 5950X is certainly helping quite a lot, as Gary is beating, you know, Lime, who's doing 2920, Wimpy. Well, actually, we should have checked the 3D Mark link, now that I think of it. Because the clock readouts and GPU-Z aren't no. Yeah, that 5950X is helping quite a lot in this scenario. But still, like, that's how the benchmark works, you know, so. And I'm pretty sure Lime is on a 5950X as well. And Lime didn't disable his cores, did he? Nope, he didn't. Or more like, didn't disable his SMT. Yeah, you need to disable your SMT if you're going to run Time Spy. Like, I know, like, you want to, you know, yeah, see? 16, 32, better memory, or yeah, like, better memory settings, worse score. Much worse score, because you've got too many freaking threads, and Time Spy sees 32 threads, and it freaks out, and it slows down. And there's a bunch of software that does this, where it's just like, oh, you've got too many threads. I'm just gonna run incorrectly now. So, yeah, 3D Mark Vantage is another great example of this. It's just like, if you go over, I think, 20 threads for Vantage, performance tanks. So, actually, I think it might be as soon as you go over, like, 18. Like, it's a really, like, it runs best with 16. There's a little bit of leeway above that, and then if you go significantly past that point, you just lose all of your points in the CPU test. And Time Spy is a little bit more forgiving. I think Time Spy you can get away with up to 24 threads, but 32 threads is way too many threads. And then you lose a bunch of CPU score and get beaten by people who just know how to run Time Spy correctly. So good job, Gary, on, you know, like, dialing in the 5950X for Time Spy, because, like, that the thing is, the benchmark has a CPU test. If you don't know how to do well in the CPU test, that's on you. So, yeah, congratulations to Gary SS on the top score. I mean, third place in the 6900 XT Time Spy rankings, and that is it for this week's HWbot score roundup. So, yeah, thank you for watching. Like, share, subscribe, leave any comments, questions, suggestions down in the comment section below if you'd like to support what I do here with actually hardcore overclocking. I have a Patreon. There's a link to that down in the description below. There's also the AHOC Teespring store, where you can pick up shirts, stickers, posters, you know, the usual YouTuber merch. And, yeah, it would be much appreciated if you check out the Patreon and Teespring, as they help out immensely with running the channel. And that is it for the video, so thank you for watching, and goodbye.